Good afternoon, everyone. Welcome to our challenge today on extended range sensing. I just want to let you all know that we do have this event recorded, so you're being recorded now. And I'd also like to ask that you all please remain on mute unless you are a judge, and during the Q&A, we'll open it up for that part. Also, obviously, if you're presenting, we'll have you come off of mute in that case. Again, welcome. We are presenting live from the Washington Mission Acceleration Center, and I'll talk more about that here in a minute. But to get started, my name is Angela Austin. I am a challenge program manager at National Security Innovation Network. We work with a community network of collaborators and innovators, and we encourage cross communication to get those non-traditional companies integrated into DoD to help solve problems. So as the challenge program, we're putting this challenge on here today to help identify companies that have the extended range sensing capabilities for our mission partner. And in this process, we identified 9 different companies that have technologies that they proposed that looked very promising. So we're going to hear more about them today and have some judging going on while we're doing this. So the pitchers will have the companies while they're pitching, they'll get the 5 minutes to present their technology, and then that will be followed by 5 minutes of questions and answers from the judging panel and the company themselves. We'll have a 2-minute break in between where the judges can catch up with their notes and their scoring, and then we'll move into the next company. So I'm going to turn it over to Drayden, who works here at the Washington Mission Acceleration Center. He's going to talk a little bit more about this site and what they do here. And then from there, he'll turn it over to our mission partner, Lieutenant Colonel Blake Schwartz.
Hello, everybody. My name is Drayden Kreft. I am the program manager for the Pacific Northwest Mission Acceleration Center. And PNW-MAC is an interconnected defense and collaborative defense innovation network. And our mission here is to break down barriers of entry to doing business with the DoD and DoD mission partners to bring advanced technology online. So we meet innovators where they are and provide resources, education, and opportunity to the technology that they create. And through joint efforts between the Northwest Tech Bridge and NSIN, along with 2 industry partners, Impact Washington and the Pacific Northwest Defense Coalition, the PNW-MAC continues every day to work on increasing access to companies who innovate. So if you want to get integrated within the innovation underbelly of the DoD and you are a small startup or small business that has an innovative technology, feel free to reach out, and we are happy to stimulate those connections and act as a conduit and a force multiplier for you and your small activities, but large ideas. Thank you.
I'm going to turn it over to Lieutenant Colonel Blake Schwartz.
Okay, thanks. So I'm here from the first multi-domain task force. I'm the data science chief, and we sponsored this challenge, extended range sensing challenge. And I thought that I would lay out for you what the unit does a little bit, because while one vendor is going to walk away the challenge winner after this process, the real purpose for us was to gain exposure to all the different technologies that are out there. We may pursue a relationship with more than one of the different vendors here to provide capability going forward. So as an overview of what our problem set is and what we're looking at, let me give you a little bit of background. So the first multi-domain task force, one of eventually it's going to be 5 multi-domain task forces for the Army. We're focused on the Pacific. We're the most developed multi-domain task force, centered at right here, JBLM, Washington. That's a little bit south of Seattle. And we are assigned to U.S. Army Pacific. So we're not intending to deploy over to Europe or to the Atlantic anywhere. We're focused on the Pacific. And you can see on the map, this is a slide we use to brief potential locations where we'll deploy. So big overview. Second MDTF's in Europe. They're dealing with the Ukraine situation. Third MDTF is also in the Pacific. They're headquartered in Hawaii, and they're building up capability right now. They're a few years behind us. And then 4th and 5th are not yet stood up. Looks like 4th is also going to be in the Pacific. And fifth, I think, will be continental US deployable anywhere, but that's a little bit flexible still. So for first though, for this challenge, I lay that out there for you because you may have a relationship to pursue with other MDTF forces in the future as well. So for us though, we are typically spend a lot of time in the first island chain. So we're getting ready right now, deploying to Japan for the next few months. After that, in early 24, we're going to spend months and months in the Philippines. So based at JBLM, it's spending a lot of time forward in the Pacific. We take technologies that the Army gives us. We take technologies to experiment with that we purchase through Army Pacific and through other Army partners. If you're familiar with some of the other advanced acquisition and experimental acquisition partners, RICTO, Defense Innovations Unit, DIU, some of the other, and NSIN, of course. So we take those technologies and try to experiment with them in the Pacific. So the laydown here shows places we might be. Our concept is we usually deploy in small cells with a forward headquarters element. We'll call it our operations center forward, and then we'll have elements from our subordinate battalions that come together to form these multi-domain cells that you see depicted here. You can see the battalions laid out on the right. We've got a long-range fires battalion, and long-range means for Army forces really long range. We've got the long-range hypersonic weapons, the only ones in the Army right now. So we have very significant standoff with those. They also have a missile capability. That MRC, mid-range capability, is think like Tomahawk missiles. And then HIMARS batteries are normal rocket artillery that you'll see in the rest of the Army, a little bit shorter range. Our air defense battalion is going to be fielding the Army's future air defense capability. It's going to include directed energy, think lasers, microwaves, all that stuff. Also the future of kinetic air defense. Right now, they've got the Iron Dome. It's the only one in the Army fielding the Iron Dome as a bridging solution to get to what the future Army capability is going to be. And then first up on the left there, you see the multi-domain effects battalion. So Lieutenant Colonel Joe Mrazek is that battalion commander. He's one of the judges dialed in online because extended range sensing is one of the things that his formation is charged to do. You've got the ERSI extended range sensing and effects company as part of his battalion. He also has a space capability, signal company, information defense, think cyber operations. So we're the multi-domain task force because in addition to the land domain, we're flying things. That's other Army units do that too, fly UAVs and whatnot. We're interested in getting into the maritime domain some, but really the multi-domain refers to, we're also in the cyber domain, the information domain, the electronic warfare domain. So we're adding, that's the Army's concept. It's bringing together the multi-domain task forces. Then our last battalion is our support battalion. You know, any Army unit stood up, deploying, dispersed, we have to be able to sustain ourselves. So we rely on other Army forces and the joint force, of course, since we're out in the Pacific, we need air and boats and all sorts of things to sustain them. So that's kind of our overall big picture. So for the extended range sensing, the requirement is, how do I target something that's a long way away, thousands of kilometers even, I can shoot a long way, especially when we've got a near peer competitor that may be able to inhibit access to satellites and even long range communications. So we're looking for something that we'll own organically, that we can control, try to secure our control over enough that we can, you know, safeguard the telemetry to keep control over it and get the data back, the call and everything that we need to do targeting, both to target things potentially on the land, but most of our targets are maritime. You can see from you can imagine what the problem set looks like. There are a lot of ships that we need to target, and you need very live data for that. Meaning, you know, I know generally for Army forces, I get a very good grid to something, good target description. I've got the elevation. I know everything I need to target it. But that was only 6 minutes ago. Great, fire the weapon. Well, 6 minutes ago, ship's going 40 knots, like you're going to miss. It's not there anymore. Even going much slower than that, we've seen you miss. So you need very live, real-time data for targeting in the maritime domain, and that's our extended range sensing requirement. You know, satellite data does it pretty well, but we think that a lot of adversaries over there are probably degrade our access to satellite communications. So we need something organic. And then again, on the other side, for what the Army calls BDA, battle damage assessment, if you're familiar, how do you know whether you hit it or not? You need to be able to have something that will tell you whether you need to launch more munitions against it, whether it's moved out and it's no longer a threat, or whether you've sunk it, or whether it's still a threat and you need to keep doing something about it. That's for kinetic and for non-kinetic as well. If I attack something from space with a cyber weapon, how do I know whether it worked? That's a challenge. So extended range sensing kind of across domains can be a multi-domain problem as well. How do I know at long range whether an electronic warfare effect worked? Could be included as well. Okay. Any questions for the operating concept? We have just a few minutes before the first brief to stay on track, so I can take a question or two if we need to.
What current assets do you have in the extended range sensing?
So we are using a lot of borrowed assets. We'll get a UAV. We recently used the K1000 from Kraus. We got the Cobalt Sapphire UAV that we've used, but we don't own them. They're provided by the vendor, paid for one experiment or two experiments. We use them and then we come back. We don't own anything organically to do that right now. That's air-based. There's some limited range ground sensors that we have, but they don't meet the distance requirements either. So we're tying into Army and joint systems for joint radar systems that they're setting up in the theater to have more enduring access to. But that's hence this challenge. We're looking for what is the way forward for us to have something organically that we own to do this.
Any other questions? Anybody at home or around the table?
What are some other areas? Like, what's our next challenge going to be?
Yeah, we've got to look at that. So I think we were really excited about all the submissions here. So I think this is, even before pitch day, I think this challenge is a big success for us. We gained exposure to a lot of different technologies, many of which we didn't know about at all, some of which are better understood, and put our problem set out there for a lot of industries as well. So we go through a pretty detailed process to look at our capability gaps. I mean, what are we required to do? What can we do now? What's the difference between them? That's our capability gap. So we have several. Contested logistics comes to mind. How do we resupply ourselves without access to the standing network if it's degraded? That could be it. Contested communications is another one that comes to mind. So don't take it as the official next challenge, but I think there will be follow-ons. And off the top of my head, those are the two that come to mind. We'll do a little bit more staff work digging into what we want to come forward with. But and Kromarazik here says power generation and storage is another good one. I've only seen one technology that really deals with that, but you're alone on a small island. You've got requirements that's along with the sustainment. Talked about treating electricity as a commodity, just as we do fuel and everything else. Another good one that we could address coming up soon.
Great, thank you, sir. Well, with that, we have our first presenter. We have YT from Zenith Aerospace. I'd like to turn it over to you now to start your pitch.
Sure. 1 second, YT. Let me make sure I get.
Take your time.
Line.
All right.
Okay. Folks at home, could you give a thumbs up if you are seeing the Zenith Aerospace? Perfect. Thank you very much.
All right. Hello, everyone. My name is YT. I'm the co-founder and chief scientist of Zenith Aerospace. Today, I'm going to show you what Zenith is developing right now. What?
Oh, let me click it.
All right. So what we're building right now is we try to build airborne point-to-point links between big cities. The concept showing is pretty straightforward. So you have, let's say, a fleet of UAVs, you daisy chain them, each aircraft will carry 2 telecommunication payload, so they can talk to the ground or talking to the neighboring aircraft. So by doing that, we'll be able to build a direct link between 2 major cities. We're going to provide like high throughput data service as well as like extremely low latencies. So we already have commercial tractions. So we got contracts to build these networks. So to enable this network, obviously the key components you need is to have a UAVs that can fly at high altitude and can provide long endurance. So the reason we won't fly high altitude because you're not going to be blocked by the curvature of the Earth, and you can propagate signals 1,000 miles if needed. Also, we want the aircraft that have the payload capacity that can carry multiple telecommunication payloads. We want to carry significant payloads for different missions. Last but not least, you want the aircraft have low operation costs, low acquisition costs, because again, like we are designed it for not only for DoD, but also for commercial space. So we want to make sure it's economically feasible. So with that requirements, so I want to introduce you the Pegasus. So we call it a workhorse for stratospheres. So the key components to make this thing feasible is we are developing a high efficiency hybrid powertrains. So it's an internal combustion engine, then have a generator attached to that, will generate electricity to drive the propellers to fly. So we designed the aircraft in a very efficient and optimized ways. So in the end, we have a platform that can fly at 5 days at 62,000 feet. And then if we fly at medium altitude, we could achieve 8 days. And on top of that, if we add solars to the wing, add the solar extenders, you get extra few days for the missions. In terms of weight capacities, there will be 2 mission payloads for the telecommunication modules we described, one at the front and one at the tails. Combined, we can support up to 75 kilograms, or about 165 pounds in terms of weight capacities. And at the same time, we're providing about 250 watts to power the modules. The aircraft is designed to fly literally globally. So we basically designed for the worst wind condition we can see. It's literally designed to fly North Atlantic in January, where you can imagine the wind condition is pretty harsh. Overall, it can resistant to 99% of wind condition you can see worldwide. It's a pretty reliable system. We designed triple redundancy into it, relatively simple thanks to the the latest improvement in avionics, etc. The aircraft will be fully autonomous. So instead of you need a pilot behind the joystick, you just send the the mission or the command where to fly, it will fly autonomously. So we want to take advantage all the latest technology improvement in the UAV world for the past 2 decades.
2 minutes left.
All right. We also developed the telecommunication payload. So this is what we enable the the communication between aircraft. The main requirement for this payload telecommunication is you won't have that pointing accuracies, so it can talk to the aircraft like a few hundred miles away. Also, you won't cancel all the vibration introduced by airflow. So we develop our own hardware, our own software to meet that requirements. At the same time, right now we're using commercial radios that's running at 80 gigahertz. It can provide the data bandwidth about 1.25 Gbps and 40 nanosecond latency. So basically, it's real time. The radio could achieve between 500 and 800 kilometers for this radius, but basically we can swap another radius to have further distance if it's required. Very lightweight, very low power consumptions. We tested on commercial UAVs as well as hot air balloons. And what we have developed for the telecommunication radio, we can swap it with the EO sensors. So you have that pointing, tracking accuracies, and you can use for different ISR missions. And we can carry other legacy sensor payload on one platform if needed. So this is, we're not just on paper, we have demonstrated the payload in airborne tests. We have flown the scaled UAVs. And on the bottom, we're making the full-size aircraft in our warehouse. We're vertical integrated. We build everything in-house. I'll jump this slide, but this is more comparison with solar aircraft platforms you may or may not familiar with. Again, we are offering a much robust solutions at a much lower price. And we offer both GoGo and Coco models if you're interested in the solution. All right, there's some tractions. We're working with a major combat command. We also secure commercial investment from Founders Fund. We have commercial contracts signed that to build these solutions for commercial work. That's to the last slides I have. We have a lot of connections army, quite a few people from PEO Aviation that's following the progress of Zenith for the past 2 years. This is me. This is our first meeting with them. If you're interested, I do believe there could be a lot of synergies happens. And I'm open. That's the end of my presentation. I'm open to any questions.
Great, thank you so much. We'll go ahead and start the 5 minutes of Q&A. So please, if you're a judge, you feel free to take yourself off mute and ask those questions.
Hi, this is Lieutenant Colonel Benner. Could you go back like 2 slides, please?
Yes.
All right, thank you. Okay, so when you say you can swap other payloads,
Yes.
have you had any opportunity to test that, or is it just you know, based on the metrics you think you can do it?
So it's right now it's based on the matrix we can do. But again, if you look at the volumes, the weight, the powers, the aircraft itself is, give you an idea, have a wingspan about 30 meters or 100 feet. So it's, you know, you can fit most payload that people are using right now on different UAV platforms. You're not going to be limited by the volume, most likely not by the weight and power consumption as well.
What about the connection? So there's a mod payload. The word is failing me. There's a standard payload attachment called mod payload, and if your UAS is mod payload compliant, that means that any payload that is can be swapped in and out.
Yes, we could be right now. We have not looked at that,
Okay.
but again, it's the right now we're focused on the platform itself. But again, you can imagine, you know, we can make all the parts to have that connections, and that's benefits of being vertical integrated because literally we're building everything in house. So as long as we have access to requirement, we can build it in a very fast pace.
Mike, did that answer for you?
Yeah, that helps me out a bit.
Hey, this is Joe Morozic. I'm curious on the radio spectrum that you mentioned. 40 gigahertz is a little unique, I think, as we communicate in terms of having the air-to-air. I haven't seen that before. What drove you to that bandwidth?
Yes, so this is right now the for the commercial application we're using this 80 gigahertz, also known as E-band. Yes, it's definitely it's definitely not well utilized in mostly in the DoD communities, but on the commercial side, we start to see people deploy on the terrestrial systems, and that's where this radio comes from. And obviously, with that latency, with that frequency, you have a huge bandwidth advantage over existing solutions. Also, because we fly at high altitude, you know, humidity is not a big issue, so you can, you know, leverage this high frequency rate spectrums. But as I said, you know, if there's another radius, we can swap it because our main technology is mostly on the gimbal and pointing accuracies. So we can support different radius if you have anything specifically in mind.
What timeline?
Okay, no, that's helpful. I was concerned about the moisture specifically, especially if you mentioned the potential to fly lower than the 60,000 feet.
Yes, for that, you know, we probably could just switch to Ka band or Ku band, sacrifice a little bit bandwidth, but have that weather resistance if needed.
Okay, understood.
What timeline would you be looking at? Like if we were to say, yes, pursue, go for it, when would we expect to have our hands on a prototype that we could experiment with?
So if you want the radio, it's available right now. We're working with AFSOC, Air Force Special Operation Command, to deliver that under a CBER contract, but we also have like first gen prototype we already tested. So you can have pretty direct access. On the platforms right now, we plan to have the maiden flight in 2024, and we're planning to invite potential stakeholders. We're working with Southcom, CENTCOM, and DHS, all of them are interesting to come to see the maiden flight.
And to provide one to us?
Yes, we can invite everyone.
No, I mean, if we wanted to own one, like I know you're gonna build one for you for the maiden flight, but if we wanted to own one, how
Yes.
long before production would be?
Once, let's say, the design phase is ready, right now, the factory is designed to output 2 to 3 aircraft a year.
In your model, you talked about GoCo, but not GoGo. From what I heard, is that correct?
We can do go as well. So right now, Coco model seems to make more sense for us, based on the access to the customers. But we're pretty flexible. We're a startup. We can do anything if you asked.
He's listed there 4.5 million go. If we wanted to, Jim.
Okay, sorry, I missed that. Thank you. All right, and then from a launch perspective, this is a pretty sizable airframe. What size runway do you think it will require for recovery?
Yeah. So the aircraft, I'll give you an idea, wingspan is about 100 feet. So we definitely prefer a wider runways, but because the takeoff speed, the cruising speed is pretty low, and we have enough powers, so I'm not expecting you need a runway longer than like 1,000 feet. So it's pretty short distance takeoff.
Okay, but it's a hard runway that we would need, hangar space and that type of thing if we owned one, right?
Well, if you have any specific requirements for the landing and takeoff, we are looking at alternatives like can take off from the vehicle, etc. Right now, I don't have a specific requirements, but happy to work with the end users if you have those kind of requirements.
Great, thank you so much. We have to move on to the next presenter. We actually are going to have going to a 2-minute break. Judges can finalize some of their scoring, and then the next presenter, Daniel Campbell, will be up next in 2 minutes. So please hold on, we'll be back soon.
There you go. You let me know when to do next slide, and I will advance it.
Alrighty, so I'm Daniel Campbell from Drop Drone. We have 2 AFWERX Phase 1 contracts for 2 different drone navigation systems. One of them is a onboard VTOL landing sensor, enables a UAS to land in an austere environment. The other one is an infrared-based homing beacon, which enables a UAS to land in a predetermined controlled environment. The infrared beacon comes in 3 flavors. It can be a dismounted unit for contested resupply. It can also be placed onto a ground vehicle. And thirdly, the infrared beacon can be placed onto an unmanned surface vessel. Now, the concept here is that a drone with a no-ear camera can land onto a infrared beacon by detecting its longitude and latitude range from the infrared beacon. So if you can advance to the next slide for me, please. So this is the infrared beacon. So essentially a drone with a no-ear camera, when it's within range of that beacon, it can detect those 2 purple lights there, which is the infrared, enabling it to triangulate the longitude and latitude distance, knowing where to land or where to drop cargo, depending on the mission. And in terms of extending range for an austere environment, specifically within Indo-PACOM, launching and recovering a UAS onto a vessel is, in my opinion, the best way to extend range. Now, you may be asking yourself 2 things. You may be asking yourself, 1, what's the range? And 2, how do you deter from adversaries? So number 1, the range is dependent on the power supply. So that silver battery you're seeing there, that's about the size of a pinky finger, and that's for dismounted resupply. So the range from the dismounted unit is about 30 meters. However, if we're hooking up this infrared beacon to a vessel, we would use a power supply, something like a car battery. And if you hook up a car battery to that beacon, you can get well over 100 meters of range. So first you want to fly the drone either with waypoints or with the GPS if it's available. And then whenever the drone is within the detection range of that infrared, it turns off its first source of navigation, and then it turns on the infrared navigation, and it transitions from manned to unmanned at that point. Now, in terms of signature management, this device here doubles as a type of MP3 player. So when you play a song on a media device like iTunes, you see a barometer pulsating up and down. The light will pulsate based off an MP3 file. So the drone with a no-ear camera, it'll see any infrared out there, including adversary infrared, but it's only going to navigate towards the infrared that's emitting that unique signature from the MP3 file. Next slide, please.
2 minutes, Daniel.
So this is the ConOps. So you can launch and recover a UAS from either a manned vessel, an unmanned vessel, or even an unmanned underwater vessel. And that box you see on top of the USV, that's the UAS terminal, which is basically a box that launches and recovers the drone. Next slide, please. And this is a little bit more of the concept here. So really, the light that emits from the infrared beacon is dependent upon that MP3 file, like I was telling you about earlier. Next slide, please. Now, this is our UAS architecture. So what we did here is we bought a standard RC airplane off eBay, and we retrofitted a kit to retrofit fixed wing for VTOL. So it's very easy to strap those 6 motors in a vertical configuration with carbon rods. The hard part is the flight controller that coordinates thrust between the stock horizontal engine and those 6 vertical motors that we just mounted. Next slide, please. And we've taken that same architecture and we're scaling up for Group 4 UAS. So this is a ultralight plane in Italy. And again, it's got a stock horizontal motor, but we're adding on 6 vertical motors, including a flight controller that coordinates thrust between the horizontal and vertical motors. And the vehicle itself is only $15,000. We're putting in $10,000 of parts, and we're looking at a Group 4 UAS for around $25,000, which is unprecedented. Next slide, please. So these are our 2 accessories. The one on the left is the UAS payload dropper. You can drop cargo, you can drop munitions, weighs 48 grams, can drop 100 pounds. And then on the right, that's our UAS terminal, which is essentially a drone in a box, but you'll notice that it has a slimmed down profile. It doesn't open up like a clamshell. It opens up more like a garage door. Next slide, please. And yeah, so we have 2 AFWERX phase 1 contracts. We have a grant through Peter Thiel's 1517 fund. And with that, I'll open up for questions.
Yeah, thanks. That's really interesting. Can you talk about the cost? How much would it be for a complete system, IR beacon, and I'm not sure exactly what the UAS options are. You talked about a few different ones.
Daniel, you're muted.
The material cost for the infrared beacon is under $100. So of course we got to make a little bit of profit, but it'd be shockingly low. Let's put it that way. It'd be less than $10,000 for sure. And the UAS would also be substantially less than any other industry leading UAS out there, because we're not developing the vehicle. We're just retrofitting vehicles that already exist.
So for the retrofit process and everything, say if I purchased a UAS to take that cost out and gave it to you to retrofit, like what sort of cost would that be to me?
Well, let's start with the Group 4 UAS because that's so expensive. We could sell a Group 4 UAS for about $30,000. So our Group 1 UAS, be substantially less than that. Let's say the Group 1 UAS is under 10.
Makes sense.
And the reason why it's so cheap is because we're not developing the vehicle. We're selling a kit that retrofits existing fixed wing aircraft. So in theory, looking way down the road, one of our objectives here is to eventually retrofit a Cessna for VTOL. So again, add the motors in a vertical configuration, put in the flight controller.
Yeah, makes sense. And then I saw the 100-pound payload capacity. Was that for the Group 4 that you did?
No, so that's a cargo dropper. So that guy's only 48 grams. So you could put that on a Group 1 UAS. You could put that on a helicopter. It's vehicle agnostic.
Oh, I see.
However, that design is scalable for up to 10,000 pounds, but right now it can drop 100 pounds.
I see.
And I'm in early conversations with NSW regarding a requirement to drop munitions with that cargo dropper.
So it could be remote drop. It could be command drop from altitude remotely. You don't have to land it and then have somebody walk up and detach the cargo.
Correct, fully unmanned.
Okay.
Sorry, Colonel Mrazek, what's the mechanism for that cargo dropper? Like, what's the transmission path to make that actuate? Does
So
that
you'll
have to
see,
be a specific interface?
sorry for interrupting. So you'll see at the end of, if we could hop back to that slide, it has a standard PMW servo. So you just plug that servo into your standard flight controller, and then you can actuate it through your flight controller, through Mission Planner. It's the same as operating a servo.
Okay, so just some simple command from a switch that would actuate the servo then to drop something. Okay.
And you may notice that that cargo dropper is actually actuated with plastic gears.
Okay, and about how much does that weigh and require? From
48 grams. Weighs 48 grams, can drop 100 pounds.
48 grams. Okay. I'm sorry, I saw on the chart there. I should have trouble reading today.
One more for me, Daniel. How much degradation in performance of the UAS are you seeing when you add the kit for VTOL? Like, obviously, the aerodynamics are going to be changed, but can you give me a rough, like, sort of percentage? What are you seeing in loss of range when you do that?
Yeah, so across all specs in terms of range, payload, flight time, you're looking at about a 10% reduction. But the trade-off is you're retrofitting a fixed wing for VTOL. So only a 10% reduction to add the VTOL capability.
Makes sense. I get it. That's appealing. Like, we may not be launching off ships, but I'm also launching from remote locations, very few of which have runways. So that is appealing. Thank you.
There's got to be some more questions out there.
Yeah, on the VTOL kit. So are you willing to sell that to work other folks UAS then? So we could have you collaborate with another promising UAS for us in that regard?
Yes. So I'm currently at AUVSI Pathfinder, and I'm trying to make that capability available to PM UAS out of PO AVN.
Okay. Thank you.
All right, thank you. We are at time for the questions, and we're going to go into our 2 minutes break, finish up the judging scores, and we will move into Hank Scott's pitch following that.
Thank you.
I can't share my screen.
Do you want to do it that way?
1 second. I'm going to mute.
All right, I'm going to turn it over to Hank Scott with TB2 Aerospace.
Hi guys, Hank Scott, TB2, former Aussie naval aviator. I've actually spent a lot of time in the South China Sea throwing sonobuoys into the water, so have an idea of this game. We've developed a concept that is basically targeting the contested logistics space, but you'll see shortly why it makes sense here. We allow any drone to pick up any payload of any size and deliver it autonomously. It can pick up the payload autonomously, it can deliver it autonomously, whether airdrop or ground drop, and it can also go and recover it. In flight, the payload, in this case a cargo pod, provides supplemental power from within the pod to the aircraft, thus extending its range, and when it's docked, it is actually recharged by an induction charger. So for the extended sensor challenge, because we are actually payload agnostic and drone agnostic, we thought, okay, let's take a look at some sensors out there. And we've teamed up with a company called MCQ. This is the aircraft that we flew with for AWE 2022. But effectively, we've teamed up with MCQ, which is a sensor company, TRL9. They do ground-based sensors. We think we can do both a ground-based and a floating sensor that you can deploy from a ship, from a ground-based location, send it out there to do its job, whether that's ISRT, seismic, acoustic, or anything else you can possibly imagine, because we can put any payload in the pod. And if it's undersea state 3, we believe we can autonomously recover it from the water. And from the ground, we already know that we can autonomously recover MCQ is just one of the companies we could use. We could basically put any sensor in this. But the idea is a vessel, we'll take it out, unmanned surface vessel, or take out the payload, you throw it in the water, or you deliver it with a drone. Same thing off an aircraft. You could actually use, we're working with Elroy, one of the drone companies. We can fit 10 of our small Group 1 pods that all basically would be sensor pods in the back of their aircraft. They're on wing and they can deploy 10 different sensors in 10 different locations. Pretty much the same way an aircraft does, maritime patrol aircraft does with sonar buoys, except we can look above surface and below surface. And when we go on ground, we can do acoustic, seismic, radar, you name it. Pick a sensor, we'll put it in there. We've got SATCOM capability, terrestrial radio capability. This is just an example of the Ranger, which is a very small ground-based sensor with SATCOM capability. Lasts for 60 days, so tamper-proof capabilities. And what we do is we wrap our capture and alignment and docking system around it. So we basically modify an existing sensor quite simply, pretty much with 3D printed applications. And you can see that application right here. So the system that we use to come and pick up a payload requires the aircraft to navigate to within a certain distance. Then we have 3 different capture technologies. One of them is differential GPS based. We just proved that out with an Air Force STPR phase 1. And a ship-based radar system out of a company in the UK. And we also have an AI/autopilot-based system that gives me EO and IR capability. So in addition to all the sensors we can deploy, we can do tactical resupply, contested logistics. We can go from Group 1 through to Group 3. We're looking at doing CASEVAC pods. We've got seaborne sensors, counter-UAS sensors, you name it. The beauty is the aircraft doesn't change. If the aircraft needs to pick up a 150-pound payload, whether that's ammo or whether it's a sensor pod, it's irrelevant. Our aircraft, the aircraft would pick it up. This one is actually a perching version of the sensor, so we could perch on a cell phone tower. Yeah, we've got patents for all this stuff too. Here's the overall system on a small 10-kilogram lift Dragonfly, just one of our 12 drone companies we're working with. And it just shows payload. Important thing here is a dock. Our docking system allows a payload to land autonomously on a ship. No humans, no straps, no lashings, no tie downs. We don't even have to go to flying stations. We come in, land on 0-1 deck, or land on unmanned surface vehicle. It locks and docks within 3 seconds. The aircraft departs for its next mission to pick up its next payload. And there's just a rendering of an unmanned surface vessel with docks for the aircraft and docks for the payload. They use the same docking system. So whether there's an aircraft plus payload or just an aircraft, we can land, deploy, and recover from moving vessels. And that's pretty much it.
Great, thank you. We'll go ahead and start the 5 minutes of Q&A.
What's the longest range UAS that you guys have?
We're working with Elroy, so they're talking 300 Elroy aircraft. They got a bunch of money from the Air Force, so they're looking at it's a VTOL aircraft that goes on wing, so 300 to 500 pounds, and they're claiming up to 300 miles. We're building a conformal pod for them, so we get pods within a pod. We also design the larger pod, the entire aircraft size pod, and that'll be one of the targets for our CASEVAC pod. Working with LIDOS, which is a heavier lift, shorter range, 100-mile helicopter, the Psionics they call it, and Command's cargo aircraft, and they're both in the 800 to 1,400 pound category. Our bread and butter right now is 150 pound lift, and as you can see with those small sensors, that's a Group 1. So we're down with the TL aircraft, the X2 Skydios. The system doesn't change, just the physical size of what we do.
When you mention the weights, is that the payload weight or the aircraft weight?
Payload weight.
Payload weight.
Yeah.
Okay.
Yeah, we're not constrained by any numbers whatsoever. If someone says, I want this aircraft, we'll build a system to match the payload capacity of that aircraft.
Yeah, that makes sense.
So as Colonel Schwartz mentioned, the range is something that we're concerned about here in terms of the airframe. So if you're delivering a 125-pound payload, you said the larger systems are getting you out to potentially 300 miles. Is that right?
That's if we put, so we can put 3 of our Group 2 pods in a Group 3 Elroy pod and deploy them individually from airdrops. If we go to a pure quadcopter, such as the Periscope RX4 or the TRV-150, they can fly for about 14 minutes at full payload capacity. The only difference is every time you pick up one of our payloads, you're picking up a power source because we have batteries in our pod that provide supplemental power. So think of every payload as a potential gas station. But we're not going to triple that range. We're just going to allow it to work in a lily pad type mentality. It takes off from one pod, drops it off, flies under its own power to the next pod. If that pod is being recharged, then it acts like a gas station and keeps the aircraft up a lot longer. And this really works in a If you go away from that out and back delivery mentality that most of the drone space looks at and take it from an A to B, B to C, C to D mentality, we're keeping those aircraft up a lot longer just because of the supplemental power.
Have you implemented any solar capabilities?
No, we've thought about it
for
actually.
Charging stations.
We have actually thought about it, a large might roll out next to one of the docks. Yeah, absolutely. Yeah. We're looking at supercapacitors too, rather than batteries, just for takeoff and landing. They have some advantages and they recharge really quickly to solid state, good for austere environments. So our avionics rack within the pod, or in the top of whatever the payload, it could be a fuel bladder, doesn't matter. It's swappable. So it's that Mercer approach. And it can be all batteries, it can be batteries plus SATCOM, batteries plus SATCOM plus radios, whatever the case may be.
You had mentioned power within the pod. Could you kind of describe how reliant is the actual platform on that additional or supplemental power that it's getting from that particular pod? And the reason why I'm asking that is it's more towards, do I need a pod that always has additional power? Is that something that is going to be required to utilize this system, knowing we're looking at a lot of different sensor swap type options?
So the reason the pod itself, just say to take the cargo pod, has a modular rack inside it, is that battery mix may change. There may be no logic whatsoever in providing power to the aircraft, whereas there may be a case where we do nothing but power to the aircraft. We're actually got a Honeywell hydrogen fuel cell with one of our payloads. So the power transfer and data transfer we've done already on 2 different aircraft, and we flew them around and basically did everything we needed to do. My background's in avionics and weapon systems flight tests, and we basically use spring-loaded hard contacts to transfer the power. But the company we use is called ESP, and if you look at any electric aircraft out there that's got $1 billion behind them, that's the batteries they're using. They're out of Utah. So we're pretty confident with power transfer and data transfer.
Speaking of that, what's the cost?
The pod itself is cheap, a couple of grand. That basically that pyramid attachment, what you put underneath it is the payload. The batteries and avionics is what shoots the price up. And we haven't settled on batteries or avionics supplier, but the pods that we flew, the entire system, $5 grand.
Okay.
We're looking at hundreds of them, thousands of them. So giving it cheap.
For the floating version that you mentioned, the duration of that is 30 days, it says, with battery life?
Yeah, I'd like to think 30 days. I know the sensor itself, the current ground Ranger sensor has 60 days and it does SATCOM bursts. But with a larger pod, which would make sense for the maritime floating sensor, I'd look at 60 days. We'd look at keeping the drogue parachute on there to reduce its drift time, and also the ability to scupple it by command and sink it. But the ability to recover it and reuse it is one of the advantages of the system here.
Okay.
Okay, we're at time with the questions. Thank you so much. We're going to go into a 2-minute break, and we will be up next with Andrew Antonio. All right, we'll get started with Andrew Antonio from Urban Sky.
Let me make sure I've got your video gone. It disappeared on me. There we go. Okay, get a thumbs up if folks can see it. Okay, and then Andrew, we're ready when you are. Oh, just kidding, I pressed play.
Hi, everyone. My name is Andrew Antonio, and I'm the co-founder and CEO of Urban Sky. My company, Urban Sky, is a leading U.S. developer of completely novel, tactical, and controllable stratospheric balloon systems. The core innovation that we brought to market is a small, ultra lightweight, rapidly deployable, low cost, and targeted stratospheric balloon. We call them microballoons, and our DoD partners tend to think of them as their own personally deployable geostationary satellites. I'll back up. Before Urban Sky invented the microballoon, there were basically 2 categories of stratospheric balloons. Those that you see on the left, large, extremely expensive, operationally limited, long duration persistent balloons, or those that you see on the right, small, tactical, short duration weather balloons that can really fly no longer than a few days and lack effective control or target persistence. At Urban Sky, we combined the 2, leading to the first ever tactical, controllable, and highly capable stratospheric balloon. These microballoons represent a new category of C4ISR vehicles that can be launched by just one operator from virtually anywhere in less than 5 minutes. They're already rated to carry up to 25 pounds of payload. The current microballoon is fully operational and was launched over 100 times to the stratosphere, typically for missions of up to 10 hours in duration. They are stealth with little to no radar profile, operating at altitude ranges between 55 and 70,000 feet. They're extremely low cost, priced at under $15,000 per system, while also being the first ever reusable stratospheric balloon in history. Several DoD end users are already buying and using our microballoons for flight testing and training. We're also rapidly improving microballoon performance with support from the U.S. Air Force, the U.S. Army, NASA, and others. Most importantly and most relevant, we've been funded to develop a multi-week persistence and navigation into the microballoon, targeting up to 4 weeks of flight duration with just one balloon, plus an altitude control system that will allow for navigating balloons or keeping station above target areas for several weeks at a time. That work is already underway, with initial long-duration flight testing slated for this winter. We've also been funded to implement autonomous control, smart navigation, and balloon swarming into the microballoon, allowing one DoD operator to manage a constellation of hundreds of smart microballoons above a single target area. All of this work is scheduled for completion by late 2024. The microballoon either already does or will soon check the box of every stated 1 Mbps requirement. Our current system is completely operational, capable of carrying modular payloads weighing up to 25 pounds on shorter duration missions. Within just a few months, we'll be flight testing multi-week missions with smart balloon navigation and persistent maintenance of target areas. The prize money from this challenge would allow us to accelerate those efforts in key required areas. You might also wonder how they're controlled. Well, Urban Sky has invested millions of IRAD into developing the most advanced stratospheric modeling software available. Our software allows DoD operators to plan missions based on target flyover areas, and you can see here how accurate our prediction engine really is. This graphic shows predicted flight paths overlaid with actual flight trajectories, and this shows the power of tactical mobile deployment with these small balloons. You can adjust your launch point easily, allowing for precise targeting on more days than ever before. Urban Sky's flight planning and mission control software is already being distributed to U.S. Army personnel in a beta environment today. Most importantly, microballoons can be pre-programmed to stay within certain operating areas, like you see here, with an onboard redundant termination system that will autonomously initiate termination if you lose communications with the system and it begins to fly towards an area that you don't want. These microballoons also have massive potential in stratospheric swarming scenarios. Imagine launching 1,000 station-keeping long-duration microballoons at a total cost of less than $13 million. You could deploy that balloon constellation with EO payloads, comms payloads, SIGINT payloads, or even just deploy decoy payloads. Today, the cheapest way for an adversary to bring down a balloon from our altitude range was the use of a roughly $400,000 mission. That means it would cost the adversary roughly $400 million to eliminate your $13 million microballoon constellation. That's the power of tactical microballoon swarms, and it's a future we're excited to help create. Thank you, and I'd love to take any questions.
Great, let's start with the Q&A, 5 minutes.
Thanks, Andrew. This is Blake. Can you hear me first?
I can. Can you hear me, Blake?
Yeah, great. Thanks.
Great. Thank you.
So a couple things. So as you go forward, we talked about the price point now at 15,000. What's it looking like once you get the balloon to have a longer duration?
Yeah, our intention is to keep it under 20,000. There obviously is additional cost. Most of that for us, you can think of as fixed fuel in the form of ballast and lift gas. So there's additional mechanisms and electrical components that'll go into a bit more of a complex Apex flight avionics box. So it'll be a little bit more expensive. And then of course the mechanisms associated with the active ballaster. But our intention is to keep each unit under $20,000 moving forward.
And how are you getting to, I understand the station keeping well from other balloons, but how are you getting to multi-week? It's a big jump from the current, less than a day up to multi-week. How are you guys doing that?
So we had a phase one AFWERX SBIR to answer that specific question. So we did a pretty robust simulated technical feasibility study on the amount of mass we can carry on our configured balloon and what that mass would relate to in terms of altitude control maneuvers. So the number of weeks is somewhat misleading in the way that it's really around the number of control maneuvers that you would want to take as an operator. And the control maneuvers we estimate to be within 60 to 80 control maneuvers over the life cycle of one vehicle with the current simulation. And our math suggests that to keep within an area that's roughly 250 kilometers in diameter, that would keep you up for 3 or 4 weeks. So that's sort of the study we completed for AFWERX.
That makes sense. Thank you. And what's the payload decrease then? I assume, we talked about 25-pound payload for short duration flight. What are we looking at for a long duration? Or what if it's a few days instead of weeks? Can you give me what that curve looks like?
Yeah, so it still needs to be built for 25 pounds, up to 25 pounds. That will mean a slightly larger balloon, but not by much. We also had a separate phase one AFWERX SBIR where we already designed. We have right now it's a 12 gore balloon, meaning 12 panels. We already designed a 14 gore balloon. That's the one that we'll commercialize with the altitude control system. That will still be rated for 25 pounds of payload mass, and that accounts for the mass we would need to carry for ballast, which is roughly 6 to 8 pounds of additional mass on ballast.
This is Lieutenant Colonel Benner. Talking about payloads staying at a constant 25 pounds. That's what I'm hearing, correct?
Or less than. It can be less
or
than
less
20.
than. So knowing that a lot of these payloads also require their own independent power, which sometimes starts at about 35 to 45 pounds, just to manage a sensor for that duration. Is there a way to accommodate that power need for those particular sensors?
There may be. I don't know in particular without maybe looking at the specific sensors. I think, our big high level comment we would like to translate to DoD is, look, we can always build a bigger balloon, right? We could always provide more capacity for mass, but we're very careful with this trade space of when the balloon gets too big, it's no longer mobily deployable by one person. And so we're trying to maintain a category for you that says, if you want to fly 50 pounds, sure, we could certainly do that, but you're moving out of the tactical space and into more of a strategic asset that requires fixed infrastructure. And so we would rather be that tactical category and ask back to you, maybe don't use this platform for 40-pound payloads. Like what do you have that fits within the 25-pound capacity that would work really well for this 3 or 4 week persistent combat?
On the tactical deployability side of things, the lifting gas you mentioned, are you going to stick with helium, or are there options to pursue other lifting gases to make that easier to transport and internationally and all that?
Yeah, we already fly hydrogen, helium, and trimix. So I would assume, and with all the partners we're working with in DoD already, you're using hydrogen so that you can produce it at the point of launch or somewhere close to it. So they're fully compatible. They've already been rated to fly with hydrogen as well.
Okay, great. Thank you.
Thank you, Andrew. We are at time for the Q&A session. We are going to roll into a 5-minute break and then get started following that with hypercalc. So we'll go ahead and start our break and we'll see you back in 5.
Go down all dramatically.
Hey, Graham, just checking in if you're going to be, oh, I see, Costa Solar. Okay, perfect. You guys are there.
That's us. Yep, we're both here. Thank you.
Perfect. We'll get started.
He has a better computer than me, so he's the CTO.
Know how it goes.
All right. Okay, well, welcome back, everyone. We'll go ahead and get started with hypercalc. We have their pitch presentation and then we'll do the Q&A following this.
Oh, that's good.
Hi, we're Hyperkelp. We build the kelp smart food. I'm Graham. I've got a PhD in ocean engineering, acoustics, and artificial intelligence. I'm a Royal Navy veteran, and I was the chief scientist in third line before I met my co-founder.
I'm Costas, Hyperkelp CTO and Graham's co-founder. I came out of NASA's Space Sciences Laboratory at UC Berkeley working on spacecraft flight hardware. I founded Blue Dot underwater drones and ran that until we co-founded Hyperkelp together. We've also got a killer set of advisors, including Pat Sullivan, who was the SES3 executive director at NASA for about 3 decades. And here's what we built: a fleet of cost-effective, persistent kelp smart foods, or KSVs. This slide shows you how all of this works together. We have multiple deployed KSVs hosting a huge selection of sensors on the ocean's surface. And they use any available comms pathway to deliver intelligence to our secure servers or hand it directly to a customer's common operating picture.
KSVs are a surface level platform for marine intelligence, and that gives us some major advantages. They're rapidly deployed by existing sonar launchers. They can deliver 4 times more reliable access to surface conditions over remote sensors like satellites or UAVs. And they're just 6% the cost of an equivalent satellite constellation when they're fully deployed. On the left is our civilian KSV, but on the right is what we're currently building for the Navy. It's the air deployable sonar buoy form factor, and that's going to let us tap into the DoD's vast deployment infrastructure.
Again, we're a hosted payload platform, but to give you a feel for what we can do, the next few slides are a couple examples of the missions we support. First one is this maritime counter-intrusion payload for a client operating the Bahamas. A camera triggered by a hydrophone captures panoramas of the horizon, and a powerful onboard computer vision processor classifies and alerts on nearby contacts. For the ACE combat exercise in Camp Lejeune, we hosted a number of sensors and added new capabilities on the fly according to Marine Corps requests, like a Wi-Fi sensor to detect ships, USVs, and mobile infrastructure. This was a pretty specific mission, but it illustrates our ability to treat sensor payloads as plug and play and to push over-the-air updates to address rapidly changing mission requirements and adversaries.
And one of the most urgent problem sets for our KSVs is in counter-hypersonics. This specific payload, funded by the US Navy Torch program, hosts acoustic and infrasound sensors to detect overhead hypersonic threats. And again, this is all built into a form factor that's easily deployed and deeply familiar to the warfighter. Because they're sonar buoy A size, we can launch from airplanes, helicopters, ships, and even USVs and UUVs. This means that we can efficiently layer entire regions, even oceans, with intelligent and persistent sensor platforms.
Yes, in fact, we're using this high demand counter hypersonics effort to scale our fleet to cover whole oceans. Over the next 2 years, we want to train our neural net classifier to detect high speed threats at high accuracy at sea. Then we'll prove the concept with a small number of buoys, including drop testing.
And we've already got the buy-in to get this scaled as soon as that work is complete. We have real traction with real customers, including the Office of Naval Research, Air Force 611th, and NAVAIR. On the commercial and civilian side, we've worked for NOAA, we've hosted subsurface payloads for Northrop Grumman, we just closed a teaming agreement with Booz Allen Hamilton to serve the Department of Homeland Security. So thank you for your consideration, and we look forward to your questions.
This is Colonel Mrazek. I had a bit of a hard time there for some of that. I just wanted to see the backhaul for those buoys. What's the comms architecture that's built in there, and how do you transmit that back? Is it limited to SATCOM, or is it flexible?
Yeah, of course. we are not limited to any comms pathway. Right now, our go-to is SATCOM. We like to use Iridium, but we've done this in the past a couple of years ago already, where we've hosted hardware to host mesh networks at sea on the buoys. We can use, we often use 4G cell. We can use Wi-Fi if we're close enough to a network. So just like we are payload agnostic, we are also comms agnostic, and we can switch to another one at a moment's notice. One thing we're working with Deloitte on right now, just as an example of the comms we can host, is Link 16. So those are a bunch of examples, I think, to illustrate the actual answer.
No, that's great. And from a mod compliance perspective or payload interface standards, do you comply with that soft mod compliance standard, or do you have a specific interface that you require for the, like if we wanted to swap out different payloads?
Yeah, we try to be sort of off the shelf, so we can host right now any USB, I2C, NMEA. We can actually take sensors that use Wi-Fi to transmit data as well, and Bluetooth. So they're sort of commercially available. We are not the UAS mod compliant though.
So speaking of that, we would need probably to deploy from a UAS with the current concept. But if we wanted to put a decent sized constellation out, is there any look at being able to launch them from a ground system? You know, I don't have airplanes or ships, but if I want to put these afloat, could I launch them out of something from the ground and have them survive to use?
Yes, you can. Our systems last for years at a time at sea, and we also basically to justify our forecast for lifetime in areas of operation. We have extensively modeled surface currents in the ocean. So if you want to get your buoys to a specific area in like the South China Sea, for example, we can run those models in reverse to tell you which land-based sites to launch these from.
Mm-hmm.
And is that software included as part of what you're pitching today?
It actually wasn't, but it can be if the customer ends up needing it. Yeah, we've got it integrated into our ODAS dashboard setup. So anyone who's using a buoy, we can actually give them access to that as well.
What can it cost per buoy?
The sonobuoys are $15,000 each. The bigger civilian buoys are about $20,000 each. Base price is $18,000 for those. So we're a little reverse. We charge less for defense systems just because we know and we appreciate that those are going to be deployed in much higher quantities, and we can actually get the government a better deal on that.
And that doesn't include the Link 16 radio.
Yeah, it does not include Link 16 modems.
What about power? I mean, if the thing's going to endure for, I can't imagine we'd need it for 15 years, but how do you approach power for the sensors?
Yeah.
And
yeah, we built this thing originally for the original design was for NOAA, and they wanted this thing to be affordable and long lasting. So we did we spent probably about 6 months just working on the power budget. So every component in here is SIPS power. We have a very powerful power management module as well that will turn power off and on to things as and when they need them. And we did a lot of simulation work about how much solar energy is available. And we proved that we can, between 70 north and 70 south, we have about 3 watts available permanently. If we go past those 2 latitudes, we'd have to go into a bit more careful power budgeting, but we reckon we can get through most winters up to about 80 north, 80 south.
You're not capturing any from the current?
Capturing power from the currents? No.
Yeah.
No.
All right, well, that is our minutes there in time. Thank you so much. We appreciate you both being here. And we're going to move on to Sarah Jennings.
Thank you.
All right, thanks.
I'm sorry, 2 minutes pause before that, and I will introduce Sarah Jennings soon. Okay, we're going to get started with Orion Robotics Labs.
Hello, my name is Sarah Jennings, CEO of Orion Labs. Orion Labs was founded in 2019 and is based in rural northern Colorado. It's a woman-owned startup focused on sensing technologies. Orion Labs has a small, innovative team with diverse expertise in sensing solutions, electronics, radar, Earth observation, and autonomy. Orion Labs proposes using Aerostar's existing suborbital long-duration flight and payload capabilities and building additional capacity for long-range sensing and autonomy. Aerostar has over 65 years of experience. Their balloons are self-powered, can fly for 30 days or more, have a payload capacity of 125 pounds, and utilize vertical takeoff and landing. They use Silvus and Iridium and have a variety of operational tools. They can carry IR, NSIN, and EO payloads. They are mod compliant and are able to be launched and recovered by a team of 6 people. Orion Labs has worked with Aerostar on multiple suborbital flights with several weeks of duration of cumulative flight time. Based on our previous experience working with Aerostar, we believe that they are the perfect flight provider to continue advancing our capabilities. On our previous mission, we were able to integrate our payload technology seamlessly with their flight and gondola system. Our payload was used to detect and confirm jams and atmospheric gravity waves using RGB imagery. During our flight, we also collected additional data continuously, including IR imagery, GNSS data, temperature, and pressure. We had 2 compute units on board that were used to run machine learning and quantum machine learning models in flight. Our payload technology demonstration showed detection capabilities, onboard processing or edge computing, continuous data collection, live monitoring, and live data backhaul. Building off of our previous success that brought our technology to TRL6, we believe we can expand our capabilities to include RF signal change detection, smoke detection in both IR and in RGB, and object detection of targets such as boats or planes. We know that upper atmospheric wind conditions can negatively affect suborbital flights and reduces useful mission flight time. With our extensive background in robotics, we can address these issues by developing a system to increase the maneuverability, predictability, and ease of operation difficulties via autonomy. The solution would manage execution of station keeping and station change requests made by ground operators. The system would utilize altitude control, vector thrust, and wind speed and direction prediction to perform the necessary mobilization to achieve the station keeping or change target. These new systems may also have additional use cases outside an autonomous system. Wind speed and direction modeling and prediction can also be used by operators during their own planning phase for maneuvers. Vector thrust capabilities, either utilizing traditional electric-driven propellers or solid rocket motors, could also enable evasive maneuvers to be executed in rapid time. Our costs will be under the $2 million threshold. There is a market for these capabilities outside of the DoD within the agriculture sector and Earth observation markets. There is existing technology for both flight, payload, and certain capabilities, such as live data backhaul, that are ready to be demonstrated today. Additional capabilities will need some development and integration time and will be dependent on the interest of one MDTF. Our team developed our first payload from idea to execution within less than a year. We have a small, agile team, and we believe we can work with one MDTF to meet your budgets, timeframes, and build valuable solutions together. Thank you for your time.
Great, we'll go ahead and start with the Q&A.
Hi, Sarah, thanks. Can you elaborate on what exactly could be provided today if we took it forward for an exercise to use?
Yes, so today we have the payload itself, which does have imagery capabilities in both RGB and IR. It also has that live data backhaul, the continuous monitoring. We have a GNSS capabilities, an IMU. We have a Geiger counter, and we had a temperature and pressure sensor.
This also building off that leverages the detection models as well. So all of that sensing capability
really is driven to make sure we can test out both the regular traditional machine learning and quantum machine learning models in the air.
So you're okay. So you've got a machine learning model in the air doing object detection. Is that?
Yeah. So currently, what we had flown for our 2 missions was for object detection of atmospheric gravity waves and of dam detection. And we were at about 70,000 feet for our second mission and 100,000 feet for our first mission.
And how are you doing backhaul?
So we had a series of communication loop between the payload and on the ground servers and our live monitoring tools.
So we used an open source sort of client server software that was modified for a particular application, and then the data was transmitted all over the Silvus communication system that Aerostar provided.
And then one more for me. Which Aerostar balloon is it? What's the size of the balloon you guys are using with them for, you know, how many people does it take to launch, let's say?
Yeah, so we used 2 different types of balloons. The first balloon, I don't remember the exact name, where it had the capabilities to go to 100,000 feet, but less of the maneuverability. The second one that we flew on was a Thunderhead.
On that, what is the size and weight of your payload? Is it something like in the 100-pound range, or is it smaller?
Yeah, so our payload is around 10 pounds, and it's about, I think, 20 inches by 20 inches in size and about 5 inches tall.
It's actually right here
Yeah.
in the background if you care to see it. Most of the width actually comes from this heat radiator. That the rest of it's kind of very compact.
Got it. And so it's not necessarily tied to Aerostar. That's just how you've done your test flights, right?
Yes.
Okay.
So on that note, then, if what would be the cost without the balloon? What if I owned a balloon and I said, hey, can we use your sensor and your machine learning model and your backhaul mechanism? How much would that cost us?
Yeah, so it's really dependent on what you would like to do, but I can tell you that our payload to develop it initially was under 500,000, and this would be significantly lower, you know, depending on what sensors you wanted to use to be able to replicate that.
No one else, I'll ask another one. So what other machine learning are you working on, if any, other than object detection? Like if we were to put, say, electronic sensing and some sort of camera, are you looking at any combined model that could intelligently merge 2 sources of information? It's something that I haven't seen done well by anyone really.
Yeah, that's definitely something that we could do right now. We haven't had the need to do that. One of the things that we wanted to do is to be able to run both our IR images as well as our RGB images. But again, that's for object detection. But our team has done other types of machine learning models like time series, LSTMs, things like that.
We also have other projects that we're working on that aren't necessarily directly related to this, but are related to fusing data from different data sets and it utilizes machine learning in some of it, but not all of it. We use traditional sensor fusion techniques for both radar, fusing radar data with camera data as well as another example of algorithms that we work on.
Sorry, could you, this is Lieutenant Colonel Benner. Could you please review with me again, like the range of your sensor? What type of quality data do you need? Because some object detection is really dependent on the quality of the images themselves. They don't do very well with fuzzy images or poor quality or things that are obscured.
Yeah, I can tell you what we used for the resolution for the images. So for one of our flights, it was around 4.93 meters per pixel for the resolution. We trained the models actually on several different types of data sets at different resolutions and different altitudes. So But again, you do get varying results based on the image quality and the data that you feed it in.
Okay, and then how long does it take to train for a single model? Or what is the data requirement and how long does that usually take?
Last question, please. Thank you.
Yep. So we trained our models over the course of several months, and we did it at different intervals with the different numbers of image sets to see which ones would perform better. But we actually did conduct a QML training while in flight. So it was just a few hours.
Okay,
on a small data set.
Great, thank you, Sarah. We'll go ahead and move into the 2-minute period of catching up with the scoring. And then next I will introduce Dr. Kevin Montgomery. All right, I'm going to turn it over to Dr. Kevin Montgomery. Please go ahead and get started.
Great, thanks. Man, this has been great watching everybody's presentations and stuff. And so I'm going to make it easy for you guys. This is all great stuff. I just want to make the comms. That's what we're really all about, is the comms and the kind of sensor platform. I don't have a balloon. I don't have all the other cool stuff these guys have. But man, I want to work with everybody and collaborate with them on here. Next slide, Brady, if you would. So the background, I was a research professor for about 16 years, and actually this company spun out of my lab at Stanford. Hooked up with a friend of mine that was a Cisco executive, and that's IoT AI. What we've really been doing is trying to push the state of the art and what we will need for this next generation fight. And that really comes down to a platform that's the world's most advanced for LPI, LPD communications, pushing beyond the state of the art of that, mesh technology, and a lot of other things that you're seeing, all put together into an open sensor communications and edge computing platform. Next slide. All right, so here's the deal about the platform. This is actually our 4th generation platform. We deployed these sensors and devices made from them all over the world, from wettest place on earth in Hawaii, Southeast Asia, sands of Iraq, Fairbanks, Alaska, all over the place. It really comes down to, we've built a couple of little board sets called Pico. And I'm holding some in my hand right now. I don't know if you can see them, but they're basically our 4th generation devices, and they snap together like IoT Legos. So here's a processor option, here's a processor option, here's a radio, here's a sensor board, and they all snap together. That allows us to make all kinds of really useful things. Completely open system, has a TAC server built into it, really easy for anybody to interface it to some other sort of sensor, but it natively already supports 4,000 different types of sensors that I'm happy to go into of every interface you can possibly think of. Ultra low size, weight, power, 40 millimeters by 50 millimeters, and can be plugged together. As far as power, nominally less than half a watt for most of what it does. Even with our higher end processor that does something pretty similar to an NVIDIA Jetson with full AI ML engine running, we're at 3 watts. But almost always we're turning off all the cores except the one we're using, so we're always saving a lot of power. And we've done a lot of work self-powered as well, as I'm sure you're going to ask about. So what we're really about, though, is that next generation LPI LPD. So let me give you some numbers. We have a SOCOM funded project for doing UAV communications. I just tested it about a month and a half ago down at their test range. We were doing command and control of UAV, and we were only detectable from 13 meters away. Even at full power on our radios, we're only detectable from 153 meters away. And we've tested those radios to 50 miles unobstructed line of sight. And the way that it does it is it's a unique waveform. I won't go into the details of here, but it really is ultra redundantly encoding the data down to where we can pull it out from below the noise floor, along with a suite of 12 other techniques for extreme LPI, LPD communication. It's been tested in a bunch of different exercises. I'll give you some more examples in a minute. On top of that, we built a next generation wireless mesh network that's 2 orders of magnitude more effective, efficient, and scalable than anything anybody's ever produced before. The way I know that is I've read 136 papers of how everybody else did mesh networking, paced around the conference room next door for 2.5 years, and came up with another big advance beyond it, where we've tested it to over 10,000 nodes, and all of them operating and being able to communicate at the same time. 10,000 nodes would cover continental United States using our existing radio and form a mesh network in less than 6 minutes. That's really our core special sauce. It's all self-configuring, self-healing, and dynamic. Every 10 seconds, it re-optimizes the mesh network to give you the best mesh network you could possibly have, taking into account detectability, RF, signal strength, latency, and load, even for things like teleoperative control. We've then taken all this technology from these little boards that I showed you and built it into a number of different applications and devices, from comms backpack for ATAC devices, for LPI, LPD communication, contested logistics asset tags, aircrew alerting devices for nuclear bomber crews. But the one that I'm here to really talk with you about is this, which was the Smart Rock. This was funded by SOCOM, and basically it's a EW detection, deception, disruption device. Most important thing to remember about Smart Rock is it doesn't need to be a rock. We built it into a brick on a building, and what we just tested the last 2 weeks with SEAL Team 18 off of Norfolk is Smart Jump. It's got a software-defined radio in it that does 1 megahertz to 6 gigahertz. It does triangulation of multiple RF sources that it detects among that sea of C junk. We commanded and controlled it remotely via USVs and UAVs. We deployed them automatically from USVs. And again, if I bounce data off the UAV to the sea of C junk, I could be, let's just say 30 miles up to the UAV, beyond line of sight over the horizon, commanding a bunch of these. Again, most important thing is I can take this white box out and I can put it in to anybody else's platform that you've seen before as well. Has anti-tamper built into it, designed to be cheap enough to be expendable, but it's really for the persistent, resilient comms, command and control of just about anything. Open sensor platform reconfigurable, completely interoperable, speaks cursor on target, communicate with it with an ATAC device, works with all major COP devices, 4,000 different sensors. I mentioned that we just tested this was with SEAL Team 18 off Norfolk, USV command and control, USV deployment, bounce data off of UAVs, silent swarm. We use this to deceive and spoof radar. We did at the other. Okay, loss of deception and disruption. The idea is deploy these, triangulate, and also be able to command and control remotely and deceive and disrupt your adversary's communications as well. I'll end there.
Great, thanks so much. We'll start with the Q&A.
So if this is going on to a network that we have, what level is it accredited to? Do you have an ATO to get it on classified networks?
So I have 2 questions actually, RMF and ATO and classified. I'm trying to keep everything unclass, and everything we're doing right now is unclass because I don't want really the restrictions on the operationalization of it that will run into classified, but it is all prepared to go in that direction. And we do have a classified contract we won't talk about here where we'll probably do that. As far as ATO and RMF, the paperwork is all into EMAS. We're about 80% done. The RMF process for this, we've had a previous DIACAP, but we just need some sponsorship to get it over the hump and the final hurdle. So I think realistically, maybe 6 months to 8 months away from wrapping up the ATO. It may accelerate because of another project we have though.
And what would the cost look like for support for an exercise? And what would the model be for us to purchase this? So would it be you would come out and establish communications with our networks, along with our networks, or is this something we would buy and own? And then what would the cost look like for whatever the model is?
Yeah, gotcha. So, I mean, we do a lot of exercises. If Brady flips forward a few slides, you'll see a bunch. Trident Spectre, Silent Swarm, just in SEAL Team 18. Honestly, we're in the, I don't know, 100K, 150K would be really nice to just offset the labor of anything specific that you need built that it doesn't already do. From what everybody's been talking about, I think it already does a lot of what you want to do. I just need the offset for the travel costs and labor and support for supporting that which you are doing uniquely that is not covered by other projects. As far as the eventual cost right now, I'll tell you, please keep sensitive to everybody else. Ballpark $2,500 on low volume prototypes. I'm going to get under 2K probably within a month or two as we ramp up. And my eventual price, when I get below sub 1,000, I start to get expendable. And when I get, my hard floor is going to be at about 600 based on what we're doing right now, then it's completely disposable, expendable. But the idea is that basically nobody's making comms in that low cost sort of area. Everything else is really expensive. These will mesh together and then you exfil the data through any kind of uplink you've got. We've tested everything. You know, EOS, Harris, Satcom, HF Satcom, Iridium, Inmarsat, anything. We've gone over them all before. Other questions? I know that was a few miles wide and less than an inch deep.
I think that makes sense I think that makes sense to me. So how effective then is the, you covered the probability of detection well. How robust is it against interference jamming type things?
Actually, really, really good because of the waveform that we use. As I said, I can pull data literally out from below the noise floor where you're a few meters away and you can't even see it. And I'm going, up to 50 miles. So it's also extremely impervious to jamming. And I have AARs on all this, objective validations from other groups. I'm happy to share with anybody. And you can reach out to the people that did that testing. So it's extremely difficult to jam also. It also works extremely well in metal-rich environments. It actually thrives off of multipath interference. Baldestern and a Navy destroyer at all levels worked great.
Excellent.
Yeah, love to tell you more about the details sometime, but one-on-one.
Yeah, thank you very much. Yeah, we've got your contact information as well.
Thank you, sir.
Have a minute left for Q&A.
Unless Mike had any questions. I think that's everything for me.
Yeah, like I said, I'm making the platform and the comms. I want to empower all these other great folks to do what they want to do.
I do have one more then. So how long could you leave one of these deployed devices out in terms of power?
So as far as the time that we've had a sensor deployed, it's close to 20 years now. We've had one deployed in a rainforest in Hawaii as far as just, mean time between failure. How long will this operate? You know the answer. I don't know. How long do you want it to operate? How big do you want it to be? And how often are you going to transmit? If they're just out there operating and detecting, and then you're later going to fly a UAV over, and then it's going to chirp out a special code, and then they'll finally uplink their data and transmit weeks. If you want it to be bigger, I can give you probably months on that. Part of what we do is they go into extreme low power sleep. So this device is going to operate for a year, but it just wakes up infrequently. So that's all trade-off, and it's all configurable to whoever we hand it over to. If you guys want to, how often you want to transmit and how often you want it to sense. So sorry to give a wishy-washy answer, but that is the truth.
That's great. Thank you very much.
Great, thank you. We'll go into our 2 minutes break here, and then we'll come back with Sky Dweller, Michael Miller.
Thanks everybody for your time.
Thank you.
Thank you.
I'm going to turn it over to you, Michael.
Great. Thank you for the introduction, Diana. My name is Michael Miller. I'm the Director of Business Development for Sky Dweller Aero. I'm pleased to give you just kind of a short overview on our capabilities with regard to this effort. Next slide, please. So the Sky Dweller Aero was launched in 2019 to essentially focus on developing an operationally relevant pseudo-satellite capability focused on making the Solar Impulse 2 platform autonomous. So we launched in 2019 with $40 million worth of venture capital, bought the Solar Impulse 2 platform and applied for and received a OSD JCTD, or Joint Capabilities Technology Demonstration, turned AMPA, or the Autonomous Maritime Patrol Aircraft, which is led from a technical and transition manager perspective by the Navy. So we picked Solar Impulse 2 because it was the first aircraft to fly around the world on solar power. It was the first aircraft to break the solar cycle. And it flew continuously for 5 days and almost 5 nights with a pilot, all his food and water, toilet, life raft, and parachute. And last but not least, it was certified to fly over densely populated areas. So given this, our position is that a persistent air vehicle is probably going to have to be solar, and this is the only thing that was scaled to truly carry heavy and powerful payloads at long ranges and persisting overhead. Next slide, please. So as part of the AMPA JCTD and our other activities, we are or have already integrated a number of payloads to include the the Silvus ManNet, the AN2 JADNet NPU5 from Persistent Systems, also known as part of the ATAC family, 4G LTE, 4C2 of the system. We've done all the engineering for Trillium HD80. We're working on a GFE SIGINT payload for government, and several others are in process also. I shouldn't forget the Inmarsat, which is already integrated, and we're currently working on SES O3B. Also to follow is Iridium and likely Starlink on the BLOS side. In terms of capabilities, the operational envelope and altitude of the aircraft, we operate between 5,000 and 35,000 feet. Launch recover from airfields under 500 meters. We've proven our autonomous flight control systems already. And in the last 8 months, we've flown 7 times, to include a flight earlier this month with 8 touch and go landings. That's in contrast to some of the other platforms out there, which are waiting months for a launch window. We can transit for thousands of miles at about 600 to 700 nautical miles per day. And we've got waypoint routing, so we are lost link resilient. Sorry about the background noise here. Our comms architecture is designed for NSA mobile access solution support for multi-level security systems, aka commercial solutions for classified, and so it's MLS guard system capable. We're going to provide all the data in MIL standard format for the sensors. We won't do anything to the data unless someone wants it to run through a Maven edge processing node or some of these other things that we're working on integrating right now for some of the agencies out there. Overall TRL for the system is TRL 7 to 8. Next slide, please.
We have a little bit over a minute left.
All right, so we've got obviously an aircraft like this, we've got multiple opportunities for tip and queue and cooperative operations with both high altitude pseudo satellites and other medium altitude platforms. Next slide, please. This extends to the comms relay or assured precision navigation and timing in a denied environment in both single or multi-ship arrangement. Next slide, please. Lots of opportunities for SIGINT, comment, and RF geolocation with an aircraft with 236 foot wingspan and 18-foot vertical. Also, some very interesting EW options with opportunities for placement of a 10 to 20 square meter antenna. And with our current battery configuration, with its old 160 to 200 kilowatt hours of power, which will be going up significantly very soon and over the course of the next couple of years. And then one cool component of what we're doing is really the 5D weather forecasting and ops analysis piece. Next slide. And that tells you how you can actually use the platform. Are we out of time?
Yeah.
Okay.
So let's open to Q&A.
What does the timeline look like then? I got TRL 7.8 right now, but what's the timeline look like for, if you say we definitely want this, when might we see it in support of us?
Okay, so if you're talking about a demo in Westpac or in your theater, which is what I'm assuming, I think the latter half of 2024 would be the first window. If you'd like to test payloads in the Gulf or the Caribbean, then that would be available starting in the spring.
And how many aircraft do you have right now? Is it one aircraft right now?
Right. Yeah, we're currently modifying the Solar Impulse 2 platform, and we're about 2 years out from delivering the first production prototype. So what we call the current platform is SKU. So we've unmanned So we're working on unmanning the Solar Impulse 2 platform.
Hey, if I can interject real quick, two questions. One, I see a lot of the sensors operating sort of at nadir. So I don't know if that was just a slyology thing or if there's a way to project, because a lot of what we look at too is not only platform penetration, but also sensor penetration to extend the range and also ensure some additional survivability of said platform. Over. That's question one.
Yeah, appreciate that. So you want to use your altitude and your sensor standoff range. So this, the nadir piece you see here is all just slideology. I've got other slides that kind of talk about what that what the more oblique collects look like with SAR in a maritime environment, for example.
Check. Okay. And then second too, because I know Colonel Schwartz would also get to it, but we're talking about cost from one of these platforms. With what I'm looking at is your sensor, your full sensor package that you have displayed to us today.
Yeah, so this is an example sensor package. So per our last slide, our ConOps, we work with you on the location requirements for a demo and a demo event, the logistics and the comms integration. Work with you on the ops analysis and the mission planning, so we can plan exactly how, where, when, and how you could deploy the platform in different mission configurations. Also using the 5D weather planner, and then kind of scope it out and price it.
Okay.
And so there's essentially the list of assumptions that are kind of baseline assumptions that we would use, and that we've done a fair bit of ops analysis for here on the left hand side. To include launching from a base that's about 5 to 8 days away, operating a latitude at about 24.5 north and south of that point, operating to kind of a minimum state of charge of 5% of the battery. So that gives you 1 hour of level flight. So when the sun's coming up, you still have 5%. And then the payload assumption is 150 to 300 pounds with 2,000 watts of continuous power. So those are kind of the parameters that we've used for initial ops analysis.
Okay.
So I would say that Barbara's point is where Solar Impulse 2 flew on the trip between Japan and Hawaii, and Guam is what we've been speaking with some other folks about in terms of potential other events. Over.
Right. Okay.
Great, thank you so much. We'll go ahead and take our 2-minute break, and we'll be back with Diana Little.
Great, thanks you all.
Thank you.
Appreciate it.
I was there when they landed in California with the MET version.
We'll go ahead and get started. I'm going to turn it over to Diana Little, who traveled all the way from North Carolina. Thank you for being here. You can go ahead and get started.
Okay, Diana Little, Anuva Aerospace Corporation. We are a women-owned startup building low-energy lift for sustainable aviation, and I'm here to present our ultra-persistent sensor platform for maritime domain awareness. Okay, it's not going. Next. For the past 7 years, we've been working on something both ancient and revolutionary, using vacuum to lift a ship. The idea was first proposed in the 1600s, but it's only now with modern materials and our patented lifting cell design that it's become feasible. LTA vehicles offer tremendous capabilities for long-term loitering missions, such as those the Extended Range Sensing and Effects Company are responsible for. Replacing helium gas bags with partial vacuum lift cells grant unprecedented persistence and maneuverability. Our PVL cells make it possible to remain aloft and on station, not for hours or days, but potentially years at a time. Next. Got it.
Oh, it's
The
working.
National Oceanic and Atmospheric Administration has awarded NUMA a phase 1 SBIR grant to design a persistent weather balloon, which will circulate autonomously and gather weather data. The high-level software architecture pictured here leverages the AWS IoT Greengrass components and services to deliver data, and onboard machine learning will use local weather data and forecasts to navigate. While the NOAA concept will use satellites for communication, a mesh network between dirigibles and ground stations would also be effective. Partial vacuum lift is what makes this possible. Rather than logistically insecure, leaky helium that requires frequent top-ups, a PVL cell is self-ballasting. Air is let into the cell to descend, and air is pumped out of the cell to ascend, like a submarine in an ocean of air. Thin film solar cells and an onboard battery ensure continuous power to the payload and aircraft components. What this adds up to is a solar-powered aerostatic sensor platform that can circulate via wind currents in a given area, but is capable of being directed to specific locations as needed. The low energy requirements of aerostatic lift and the large surface area for solar cells allow the ships to harvest and store power, which is available for 24/7, 365 sensor readings, communications, changes in altitude, and propulsion. While they may not have the speed of a heavier than air UAV, they will already be in place when needed. When it's time to bring a ship down for maintenance or to upgrade or enhance the payload, the PBL cell's feature of zero static lift makes ground handling safer for the crew and the aircraft. We've first built small-scale test articles to ensure the patented design could stand up to the vacuum pressures, and are currently designing and running simulations on a 12-meter diameter lift demonstrator prototype. We've been awarded a grant from NOAA to design a persistent weather aerostat. This is an evolution of a concept we were invited to the pitch to the DIU last year. Our team includes current and former service members, leaders from defense, aerospace, manufacturing, and software companies, engineers, and visionaries. We've recently moved into the First Flight Venture Center incubator in RTP and are very involved with the NC Tech community. The commercial potential of the PBL cells is vast, as will be the size of the cargo airships that will be used to avoid gigatons of emissions from long-haul heavy lift transportation. On the roadmap towards that goal, we have an MOU from a communications aerostat company and are starting to explore licensing the technology. We start the NOAA grant on September 1st, and our plan is to own and operate a weather aerostat constellation, providing the weather data via API. Drone aerostats, such as what I'm presenting here, are for heavier payloads and missions that require propulsion. This one is designed for 50,000 feet and 220 pounds of payload, but the parameters are configurable. As to the requirements of the challenge, self-powered, check. Long endurance, exceptional. Capable of carrying customizable payloads up to 7 pounds, absolutely, much heavier than that. Live data backhaul, certainly. VTOL from unimproved surfaces, absolutely. And if you need it to land on the surface of the water, that will work as well. We're preparing to start a fundraising round in September to build the lift demonstrator and have an aggressive plan to build quickly from there. We believe our platform is the only one presenting here today that can provide the first multi-domain task force with the persistent long-range sensing and effects capabilities it needs for maritime domain awareness in the Pacific's tyranny of distance. Thank you.
Under 5 minutes indeed. Thank you very much. Okay, 5 minutes for Q&A.
So I think for something like this, our model for employment would be someone else probably launches it. It would be a service that comes over. Like, I don't think I'm going to take this into the Philippines and launch it from somewhere. And I don't really have the manning to put it in New Mexico and launch it 2 months earlier. So I think it would be, I schedule it with my higher headquarters because they own it. So what would the cost look like? Maybe, I know we're talking about a few years away here still, to get it as a service. Do you have an idea for what it might look like to say, I want this overhead in March and I want it for a month? Do you have an idea of what that might look like?
I have not costed out as a service. I certainly have with the weather aerostats because we intend to own and operate them ourselves. And so I have a full model of like what that operational cost looks like to us. That would be very similar in terms of operational cost. This is a 2-cell though, so it's more materials, it costs us more to build it. But it was for the weather aerostat, I think the operational cost to the operator is maybe $2 million a year.
A year, okay,
to the operator. So then, we need to put some profit in there.
yeah. And so you have the expected endurance persistence about 2 years. One, what's the limiting factor there? And then probably maintenance, I guess, but then,
Yeah.
so
It's a
two-
battery for the most part. That's actually the biggest, battery is both the most expensive piece of it and the least endurance.
Okay. And how did you arrive at 2 years? Is it modeling the power system is obviously you haven't flown it for 2 years anywhere, so
No, it's just modeling at this point.
assuming that the limiting factor then is the battery, okay.
Yeah, it could be much longer than that if we find a better battery.
Are you using Empress battery right now? In your model?
We don't know yet. We're still looking. This is for we've done more for the weather air set than we have for this.
Do you know what you're going to use to power things like communications equipment, sensors, that sort of thing? Are you intending to gather power with the
Solar.
aerostat?
Yeah.
Solar cells? Do you know how much power you expect to generate that you won't be using for the aerostat? For steering, changing altitude and stuff.
I don't offhand. I have a spreadsheet I could look at.
It sounds like the limb fact might be, well, it's power either way, whether it's a battery or whatever, but you could extend it based on how much you're harnessing. If you're staying at the same altitude and not having to adjust direction too much, then you're not using the vacuum very much. Then you might even recover over time.
And actually part of our patent is regenerative descent actually does regenerate the battery. So it's one of those things that if you're desperately being powered, you let some air and you go down, or regen your battery.
What sensors have you looked at putting on?
We've looked at commercial off the shelf. We're working with a company for the phase 1 SIVR that does a ton of sensors for other aerostats, and they're helping us choose sensors for that. But one of the things I was enjoying about this was looking at the other companies that are doing very lightweight and very, very interesting sensors. So, I mean, we're a platform, so we can put whatever on there.
Have about a minute left.
Okay. Mike, I can keep going. Do you have anything you want to ask pressing? Guess not. Okay. So so you're doing a weather one. Are you gathering weather data with the intent to inform future operations for weather modeling? One thing we're finding in the Pacific is the weather modeling is terrible.
It's terrible.
So you want to put something up and know where it's going to go. The model relies on the data, of course, and the data is really bad. So it's hard to predict where things are going to go. Is that a line that you guys are trying to?
It is, because our eventual goal is the long haul heavy lift. It's cargo airships, and one of the huge problems about flying airships, especially because they do fly through the weather, is actually understanding the weather. The weather models are changing. I'm a computer scientist, and I understand you really do need that feedback loop, and we just don't have it, especially in the atmospheric boundary layer. So that's what initiated the start of the weather systems. But we also figured it had impact for the rest of the planet. Having an earlier warning of these terrible storms would be helpful.
And are you steering well, and just the baseline weather data? Like we found, I want to fly this, the weather data is what we are predicting is bad. So we want better weather data for the AO we're operating in to fly anything. And then you're steering. You're using altitude change to steer, or are you putting a propeller or something you're doing?
So for the weather aerostat, we're just using altitude changes to steer. For this, we're putting a propeller on it.
Oh, you are?
Absolutely, yeah. Yeah, for dual cell, once you get to dual cell, you have a much higher weight that you can carry. And so we want to put propulsion on that one.
Okay.
All right, we are at time.
What is a material used for the sail?
It's a carbon fiber.
Like what color? Like T800, T1100? Okay, maybe that's too technical.
Okay.
All right, okay.
I'm going to turn it over to Brady.
So looking at our company.
He is our regional engagement principal out here in Seattle. Please go ahead.
Okay, hey, everybody, thank you. That's it. That's the last presentation. Wanted to say thank you to everybody. Specific thanks to Lieutenant Colonel Schwartz and the first multi-domain task force for being the mission partner on this. You guys have been fantastic to work with, highly engaged, and a lot of really fun problems to solve. So I love having you in the region, so I get to work with you guys. Two other mission partners around the room, Lieutenant Colonel Rex Ayers from Washington Air National Guard and Andrew Hoffmeyer, Science and Technology Advisor to First Corps. Great, nailed that. So NSIN works with mission partners all over the country. I'm the local person here in Washington and Oregon, so I get to work with folks at JBLM, folks at Keyport. But wherever you are in the country, there's an NSIN person like me who wants to work with you. So whether it's a mission partner in Alabama or a startup in California, NSIN has some folks in your neighborhood, and our entire job is to figure out how we can help DoD folks with problems and connect them with folks who can solve them, whether that's academia, startups, or anything else. So if you are interested in learning more about NSIN, you can reach out to me. You can reach out to Angela, who everyone should have her email address as well. But we exist to help solve DoD problems. These were great presentations. Thank you to everybody who presented. Thank you for everybody who applied. And we should have a decision made end of next week. Is that what we said?
Yes.
End of next week. So hang on tight.
Thanks again. We appreciate hearing from all of you and those who are here virtually and in person. We appreciate the effort to come out. I know it's not easy for everyone to come out. So I wanted to open up some breakout rooms here that I'm going to share on my screen so you all can have the next 15 minutes to go and exchange numbers if you want. So I just want to let you know.
I think this should be open. I think you
should be
able to join a breakout room if you'd like.
Yeah, there's 5 rooms there. So if you wanted to take a few minutes here and get in a room with somebody and go over, exchange information, whatever the case, we encourage you to do so. This will be open for about 15 more minutes. But again, thank you. And that ends our pitch event.